Let's discuss what's called synthetic division. So first of all, you only use this when the denominator is of the form x take away c. So for example, you could use synthetic division on this problem. Notice the denominator is x take away some real number. So what you do is you look at the denominator and you identify your c. So in this case, it's x take away some number, and that number is 2. You write that number off to the side, like so, and then you write this sort of inverted division symbol. So it's going to look like this. Okay, and then you write, you're going to write 2 rows here, and the first row, this top row, is going to be the coefficients of the polynomial in the numerator. Notice that the polynomial degree terms go from degree 3 to degree 2 to degree 0. This is missing a degree, term of degree 1, and when you're missing a term of a given degree, when you're making your way downward like that, what you do is you put a 0 where that term was. So you just write the coefficients. In this case, you write 3. That's the first coefficient. That's the leading coefficient. Next one is -7. And then it's missing a linear term, that is x to the first, and so you write a 0 in there to indicate that it's missing. And then finally, you write your constant term, 2. Okay, so next step is you take the 3 and you just bring it straight down, like so. And so people often do this. They put a little arrow indicating the 3 just got brought straight down. And next, you take the 2 and you multiply it by the number here, in this case the 3, and you get 6, and you put that number below the next coefficient. So in this case, below the -7. Then you add these together and you get -1, and then you repeat that process. 2 multiplied by -1 is -2. You put that result right here, and then you add, and you get -2. 2 multiplied by -2 is -4, and you add, and you have -2. Okay, so what's the meaning of all this? Well, it turns out these numbers, 3, -1, the first 3 numbers, 3, -1, -2, or let's put it this way. The last number is the remainder, okay? And these numbers are coefficients of a polynomial, that is coefficients of the quotient, and you get the degree, the leading degree of the quotient by subtracting 1 from the leading degree of the leading term of the numerator. So in this case, this is of degree 3, so the 3 goes with something of degree, or goes with x squared. So this corresponds to 3x squared, and then you work your way down, minus x to the first, and then that's the constant term, -2, and then it's the remainder of -2. So at the end of the day, if you wanted to write this as quotient, whenever you perform division, you can always write it as quotient plus remainder divided by divisor. You could write it as this, which is the quotient, so 3x squared minus x minus 2, so that part's your quotient. And then we can write plus the remainder, which is -2, and then divided by your divisor, which was x take away 2. So this would be our answer. We have our quotient plus our remainder. Let me write that. That's your remainder. That's what that little r was for remainder. And then in the denominator there, that's your divisor. Okay, so now that's how you perform synthetic division. Let's take another one to see what sort of other information we can get from it, and see what other options or circumstances we can run into. So let's use synthetic division to divide this polynomial divided by that one. And so once again, the denominator is of the form x take away c, so I can indeed use synthetic division. So I write the 2 off to the side, and then I do this inverted division symbol. I want to make it large in this case. And then you write the coefficients of the polynomial in the numerator. So it would be 2, +1, so 2, 1, -13, and 6. Notice that there's no 0 because all of the terms are accounted for. Degree 3, degree 2, degree 1, and constant. And then just like before, you bring it down and you have a 2. And then 2 times 2 is 4. Add those together, you get 5. Multiply to give 10. 2 times 5. Add negative 3, multiply to get negative 6, add and you get 0. So 0 is your remainder. And so your quotient is going to be 2x squared plus 5x minus 3. How did I know 2 went with x squared? Because you always start 1 degree less than the degree of the, or 1 degree less than the degree of the polynomial in the numerator. Notice that this would be plus 0 over, well, you can write plus 0 over x take away 2, because the remainder is 0. What does that mean? That means that this is equal to, if you write it out like I did before, as quotient plus remainder over divisor, this is equal to the quotient, 2x squared, plus 5x, take away 3, and then plus 0, right? Because it's plus remainder over divisor. And what that tells you when you have a remainder of 0, it tells you that this polynomial, x minus 2, went evenly into that. Why? Because I can write this, I can write that over, I can write it over 1, right? And what that means is that I can then cross multiply. So I can multiply this by 1, and I get 2x cubed plus x squared minus 13x plus 6. And that's equal to the product of these two, which is going to be x take away 2 times 2x squared plus 5x minus 3. And what I see is that the x minus 2 is a factor, right? So in other words, this polynomial can be written as x take away 2 times my quotient. And that's one of the important things about synthetic division. It's a fast way of knowing if, it's a fast way of factoring a polynomial. If you have a number here and you get a remainder of 0, that means x take away that number indeed is a factor of that polynomial. And that's one of the big ways that we're going to be using synthetic division. Okay, let's see one more example of synthetic division. So let's divide these two, and so just like before, now here you have to look at the denominator, and can this be thought of as x take away a number? It can, right? This can be thought of as x take away negative 2. So whenever it's x plus something, you have to rephrase that in terms of subtraction. So this can be written as x take away negative 2, and the reason you do that is because it's the negative 2 you'd put off to the side, not positive 2. Whatever number's out here is always the c, and so I'm basically saying that x plus 2 is thought of as x take away negative 2, x take away c, and that c goes on the outside. Okay, then you write your upside down division symbol, just like before, and you put the coefficients, which would be a 1, a negative 1, it's missing a term of degree 2, you put a 0, you put a 1 for the coefficient here, and then finally negative 2. You bring the 1 down, and then you multiply, so it's going to be negative 2, because you multiply these and you put it there. Add those together to get negative 3. Multiply to get 6. Add, you get 6. Multiply, you get negative 12. Add, you get negative 11. Multiply, you get 22. And then add, you get positive 20. So that's your remainder. So our quotient is going to be 1x cubed, just x cubed, minus 3x squared, plus 6x, take away 11. That's your quotient. So this can be written as, if you wanted to write this as quotient plus remainder over divisor, you write it as x cubed minus 3x squared plus 6x minus 11 plus the remainder, which is 20, divided by the divisor, which is x plus 2. Okay, so this example is important for another reason. If you look at the numbers that we get right here, all these values in this row after doing synthetic division, notice that they alternate in sign. Positive, negative, positive, negative, positive. So when you have that, let's write this down, that these alternate in sign. And turns out it's a little more complicated than this because you want to include 0 in the mix as well. But when you have that alternation in sign, that alternatingness in sign, that's telling you something about the relationship of negative 2 to the zeros of the numerator. So it basically provides, as we're going to see in future videos, a lower bound of the zeros of the numerator. Okay, so like I was mentioning in the previous example, is that one important example or one important application of synthetic division is to find zeros so that you could factor a polynomial. And when you have the result of synthetic division where these numbers are alternating in sign, it puts a lower bound. That is how low the zeros can be when you go to look for zeros of that polynomial, as we're going to do in future videos. Okay, until next time.